Hi, I'm Jerry Hudgins. I'm chair of the electrical engineering department, and I am a native of West Texas. I grew up in a little town called Plainview, Texas. It's in between Lubbock and Amarillo, which is in the southern part of the panhandle of Texas. I went to school, so I'll show you if you know what that is. That's Raider Red. So I went to college at Texas Tech University and grew up while I was going to school. I had a mixture of working on my granddad's farm and also having work in a research lab. And so that's what got me into graduate school, into graduate programs, and on into PhD program and so forth. Uh, I worked a little bit in New Mexico, doing some interesting research work on large pulsed power systems, what they're called. I then took a faculty position at the University of South Carolina and was there for almost 18 years. Was a department chair there for about 3 years, and then took the department chair's job here at the University of Nebraska. I've been here for 10 and a half years, having a great time out here. One of the things that I do when I'm not doing school work or engineering work is I play the drums, and so I enjoy doing that, and it's a great way to relieve stress. So it's a fun thing that I get to play with. So let's talk about electrical engineering. So what is electrical engineering? You can really think of electrical engineering as captured by these two pictures that you can see on the screen. One is kind of electronics, which embodies information, data flow, and the other one's a wind turbine, and so it embodies the idea of power and energy. And so if we capture that, so really electrical engineering is about two major things is one way to characterize it: information and energy systems. Now, how you move information, how you encode information, uh, digitize it, wireless, wired, light, all those different forms. And then that also applies to energy and power systems. How do you move energy and power around to do useful work? And so that's really a lot of electrical engineering. And it turns out that electrical energy is a very high quality form of energy, and it's, in a sense, much easier to move electrical energy around or packets of information in electrical form, and that's much more efficient than mechanical or chemical systems generally. And so that's why there's a big push. You see more and more electrification in applications and systems, and it's for that reason, because electrical energy is a very high quality compact form of energy, and you can structure information around that, and encode information in that form, and so it makes it very efficient systems for doing that. Now, electrical engineering includes a few other things that are associated with it. Computer engineering is a subdiscipline that grew out of electrical engineering. It's a very important field. In most places, you'll have electrical and computer engineering very tightly coupled together. Another area that is an important has a relation to electrical engineering is the bioengineering area. Bioengineering area grew really out of electrical engineering and mechanical engineering fields, and in some cases it's kind of become its own discipline, but in many places it's very interdisciplinary because of its roots, and that's true here as well. So one of the things that I'll tell you about is, as we're talking about this, is when I went into electrical engineering, my mom always asked me the question, well, so are you going to be able to fix my TV once you have an electrical engineering degree? So I'll tell you what my answer was uh, after I graduated. So I gave her an answer to that question. So one of the things that I want to impart to you is that the electrical engineering field is very broad. So it is the electrical engineers belong to a professional society called the IEEE. It's the Institute of Electrical and Electronics Engineers. It is the largest technical organization in the world, has over 430,000 members, and has a huge number of technical disciplines and technical fields under that IEEE umbrella. So I just pulled up a quick list here. You can see, and I highlighted a couple of them that may be of interest, but there are many in this list. Aerospace and electronic systems, communications systems, computer society, superconductivity council, engineering and medicine and biology, geosciences and remote sensing society, the photonic society, so that's all the lasers and optical systems kinds of things, nanotechnology council, neural network society, nuclear and plasma sciences, oceanic engineering, power and energy society, so that's kind of the traditional power systems, utility grid, electric grid kind of things that you think of, robotics and automation society, there's vehicular technology society, many more different disciplines and technical organizations within IEEE, which kind of gives you a flavor of the electrical engineering field broadly. One of the interesting parts as well is there's a great interest in how technology affects humanity, and so there's actually an IEEE society on social implications of technology, and so that gets sort of more into the, what's the effect, say, of social media with say school performance and things like that. So there's an organization that deals with those kinds of issues. One of the big pushes in the last decade, of course, is electrical engineering technologies and disciplines into life sciences, and so there's a lot of activity that electrical engineers do in terms of life sciences, from materials into electronic systems, encoders, and so forth, diagnostics, and there's a whole list there. Cloud computing is another area, so you can think of big data. That's a fancy word right now, fancy term for handling large amounts of data. Cloud computing, moving things into the cloud, how you structure information flow into and out of the cloud, so forth. Smart grid technology, again, this embodies a marriage between communication systems, sensor technology, data collection, data analysis, so forth, and also the power and energy part of the electric grid, and how you control that, who controls pieces of that, and so forth, to make that more efficient. Of course, we all know about more electrified transportation, so we got lots of hybrid electric cars around and fully EVs. In fact, I drive an electric car. I have a Nissan Leaf that's a fully electric car, so I use it to drive back and forth to work, and there's a picture of a Leaf there in front of you. So it's gets about 80 miles on a full charge there, which is fine for a commuting vehicle, and does me quite well getting back and forth to work. So again, just to hit some highlights there on the field, communications is a big area, computer systems and all the things that go with that, from the hardware design of computer systems, the actual electronics, the chips, integrated circuits, from the processing chips, memory chips, those sort of things, how you connect all that to the architecture, to software, how you do computer programming and encode information, and how that ties down into the machine, and then all the associated applications, of course, that go with computers that are infinite, and broadly digital systems. Again, energy systems, a big part of that now, besides a smart grid, of course, is renewable energy. Solar and wind energy in particular is a big area. Transportation electrification, again, is a big push. We're doing a lot of projects in that here at Nebraska as well. Nanotechnology is kind of on the material side, and that's structuring materials sort of atom by atom, and making some new types of materials, new kinds of applications, new devices, and so forth. Lots of work going on in optics, wireless systems. Right now it's wireless communications, but there's work going on in wireless power transfer and things like that. So maybe one of these days we'll have an electric grid with no distribution and transmission wires, so we'll see. Let's talk a little bit more about the electrical engineering field here at Nebraska. So the kinds of things that you can get involved in, we ask you to complete a core in circuits, electronics, systems, and signals, programming, computer programming, and computer control. So I would call that smart chip control, microprocessors, and so forth. And so that's kind of the core of our program. And in addition to that, on the physical electronics side, is a little bit on electronic devices and electromagnetic field theory. Of course, that's important in communication systems primarily, but also other areas. And then in the junior and senior year, you have opportunity to take lots of electives. So you can take 27 credit hours of electives in the program. The program allows you to take 15 hours that of those technical electives that are not in double E. 12 have to be in double E area. And so we have some concentration areas set up for you. Bioengineering systems is one of those. We have a big push in bioengineering, and in particular right now we're doing a lot of work in bioinformatics area. Have some outstanding folks working in that area. Power and energy systems again, so that's again smart grid, renewable energy systems, and all the associated controls, reliability, components, design, power electronics. There's a whole bunch of pieces to that. Communications and signal processing, and that is pretty much like it sounds, but that's all the way from data structures, data algorithms, data compression, how you encode information, all kinds of coding theory, into the hard layer of communications with electronics and transmitters, receivers, digitizers, all those sort of things as well. Microwaves, optics, electronics, so that's kind of wireless stuff. We really focus on optics and laser systems, and it has all kinds of applications for medical applications, diagnostics, surgery, all kinds of measurement schemes that you can do optically that are non-invasive, and then other applications in all kinds of construction, materials processing, semiconductor processing, electronics design, and so forth. So a huge area in sort of the optics field broadly, photonics area. Electronics design, so the nuts and bolts of how do you actually design electronic circuits, even designing electronic components, and put all those things together to say, what the heck goes into a cell phone? There's a lot of electronic design that goes into a cell phone. So how would you design that? Well, you can learn those kinds of technologies in our program. And then related to that is computer engineering on the hardware side and so forth. And then, of course, there's the software piece of that, which you can also study as well, and the programming and how you program, how you do information flow and data flow, data analysis from the software side. Then we get into the materials, again, the nanotechnology, back to photonics again, materials processing, material growth, so forth, so you can get into that. And if you sort of have a bent towards physics, solid state physics, that's a good area to get into. That's one of my areas that I always have a fondness for. I have a background in that, and so I got into semiconductor devices, semiconductor materials, and so it was allowed me to really connect a lot of physics that I was doing and mathematics and electrical engineering work. And then we also have an option, you can do a research concentration, and that's particularly important if you're thinking about going to graduate school. So that's an option that we can discuss, and we'll get you hooked up with an advisor. And while I'm thinking about it, when you talk to your advisors, you should discuss with them internship options for particularly after your sophomore year. After you complete your second year, a lot of companies are looking for summer interns and co-op positions where you go to school for a semester and then you'll go work for a semester and then probably a summer that connects to it. And so you'll be out of school for about 9 months. Then you come back to school for another semester and so forth. So it adds about a year to your graduation. But the great thing is that when you're done, you have a lot of experience. You typically get to pick and choose who you want to work for. Companies are lined up to make offers, job offers for you, and you get typically a higher starting salary. So I would really encourage you to look into co-op and intern program to get that experience, because that's really important by the time you finish school. And of course, we're interested, to talk to you about graduate programs as well. Whether you stay here and go to graduate school or maybe go someplace else to go to graduate school, we want to discuss that with you as well. Now, Students that do internships and also take full-time jobs go into all kinds of companies, both in Nebraska and also out of state, and even internationally. So small companies, big companies. So I have companies that are relatively small, like Lincoln Electric System, say it's a fairly small utility. Nebraska Public Power is a medium-sized utility. It's fairly big for Nebraska, but it's in the scale of things, it's a size utility. Uh, Go to work for a biosciences company like Lycor here in town. There are some medical diagnostics companies here in Nebraska. There is Nucor Steel has opportunities for hiring electrical engineers here in state, and then you can many other opportunities in state. Then you go regionally. You've got big consulting companies, construction companies, Burns and McDonnell, Black and Beach, so forth. Then you've got companies, other utility companies. You've got companies like Garmin that hire our graduates. We have companies like Boeing, Texas Instruments, Intel, General Electric, so forth. So it's just about any size company, from a small startup company doing software design to large international companies, so that you can end up working anywhere in the world, depending on what your interests are and what your job qualifications are. So, basically the sky's the limit. We have a lot of students that have worked overseas for various companies, so there's a good opportunity to do that if you have an interest in that, and particularly if you have language skills. That's a fabulous opportunity to take advantage of as well. Now, here at home, we have a couple of student organizations that you want to get involved in. We have a student branch of the IEEE, again, the Institute of Electrical and Electronics Engineers, and so we have a student branch of that organization. We have an honor society for electrical and computer engineers, which is Eta Kappa Nu, that you might be able to participate in. And then, of course, the engineering organizations. There's both student advisory committees at the college and in the department, and then, of course, Honor Society, Tau Beta Pi, and so forth. And there's Society of Women Engineers here in the college. So, and some other organizations in the college that you might want to look at, and then certainly want you to become active in the student branch of IEEE. Okay, so let me finish up and answer the question that my mom posed to me when I first started school. So she asked, okay, you want to be an electrical engineer? So of course, for her, big electronic thing for her at that time was, this was sort of predates home computers, and so she said, well, can you fix my TV when you get out of school? So I said, well, I'm not sure. Probably, but I'm not sure. So after I graduated, I had a better answer for her. I said, Mom, I said, I'm going to answer your question. I said, yes, I can. I think I can fix your TV now, but you can't afford me. So that was my response. Anyway, hope you enjoy the electrical engineering program, and look forward to seeing you in class.